Hi, Ken. Can you hear me?
Yes, I can.
I
Welcome.
am so sorry for that last when I was at that conference. It was kind of funny, but kind of not because we were in the middle of a this wonderful high level briefing, and John Beverly pointed at me. He was on the stage. He's like, "You're on a call." I was like, "Oh my gosh, I totally." And then the technology was just a nightmare. So I apologize for what happened last time.
Yeah, these things happen. Well, people are showing up. That's good.
Yeah, we can wait. I'll keep prepping here. I didn't send slides because this is actually kind of like more of a live. I want to walk you through what went down, and then if we think it's worthy of some screenshots, I will be happy to convert this into a slide deck.
Can you can you try sharing the screen just to make sure
Yeah,
that works?
yeah, absolutely. Where is the? Oh, I'm used to Teams. Here it is. Okay, got it. We will share that screen. Screen 3. Okay, that should be coming up. Can you see my web protege?
Yeah, I see it.
Okay.
A little hard to read.
Well, I can make the point without really
No,
reading
that
it
that's
too
all
much.
right. I mean,
Yeah,
I'm sure we're familiar with
yeah,
everyone would be familiar with protege.
yeah, yeah.
Okay, well, why don't you put that the protege back?
Here, I'm going to start with this right here. Okay. Can you see my PowerPoint slide there from?
Oh, that's good. Why don't you put it in full screen?
Yeah, let's see if that will do that. Full screen. Oh, it went on my other screen. Let me, I'm going to share my other screen because it
Slide
went,
share.
I've got these screens going here. Let's go share screen 2. There we go. There we go.
That's good.
Good.
Okay, let's get started. Welcome everyone to the Ontology Summit 2026. Today is the 10th of June, 2026, and we're pleased to have Bill Mandrick speaking today on Ontology Engineering 101 from expert knowledge to ontological models. Bill is a senior ontologist at the CalSpan University at Buffalo Research Center. I got that right.
That's right.
And is a retired U.S. Army colonel whose work has focused on ontology development, OWL RDF representation, basic formal ontology compliance, and military intelligence applications of ontology. Bill is a longtime contributor to early military ontology work and best practices work in ontology development. He's a co-author with Barry Smith on the philosophical foundations of intelligence collection and analysis, including the role of BFO and the Common Core ontologies in semantic interoperability for intelligence systems. So Bill is the chair of a successful weekly working group on Ontology 101, sponsored by NCORE. So with that, Bill, can you take it over?
Yeah, thank you. Yeah, so that was a very nice introduction. Thank you. So the weekly call that we have, it's on Teams. We call it Ontology 101, but I don't know if that's the right uh, label for it, because we get some really um, we get some high level experts on there, and they already know ontology, a lot of them. So in other words, it kind of takes on a life of its own. We try to do 6 week increments, and the intent of it is to get someone who's interested in becoming an ontologist to come in and get 6 weeks worth of, like, hey, this is how I get started. Well, that doesn't usually happen. And the last time we did this, the last iteration, we had this fellow from he was in the international trade domain, specifically international trade situations where we're importing things like folic acid or other supplements or other ingredients for supplements. So he came on the call, and he had a certain list of questions or problems that he had. And so these right here, this was the slide you're looking at. You can kind of just read over that. This slide came into focus after our 6 week session. He had these problems and these questions that he had, that he felt as though a knowledge graph and an ontology could help him. And what I'm going to show you today is how we walk through this process with him. And he did a lot of work, and he was a natural at developing classes and relationships. So I'm going to come back to this slide deck. And the reason I don't have a slide deck is because I'm going to walk you through kind of what we did. And so step number one was we developed what we call, and I'm going to bring them up for you. Just give me a second here. Okay, so tell me, someone give me a thumbs up, or yeah, we can see it. My spreadsheet here. Can you all see that?
Yeah, we can see it.
Okay, so the first thing we did with Daniel was we said, okay, Daniel, what we call these, let's go, I'll go by column here. Column B there. I'll make that a little bit bigger. So column B is what we call it. When I was in aerospace, we had these things called decision support questions. And what that was that's an expert who's not an ontologist, who's not a data modeler or data person. They're in management, or they're in an executive position, and they have a question in their mind. We'll call that, it's a question in their area of expertise, and it's obviously expressed in natural language, the way experts talk. And as we know, experts can be vague. They talk to each other, and they say things that, like, yeah, we know what we mean, but to get that in a knowledge graph is a whole different story. And that's kind of the story I'm telling here today. So column B here is where we started with Daniel. We're like, Daniel, give us a give us 3 to 5 questions that we can start with, low hanging fruit. Well, it's 3 to 5. It blew out into like 70. But here's some examples of some questions that he had, and it would call that first column there, FA, that's folic acid, because that was the example, the use case he used. So you can see the questions: what's the country of origin? What countries is it shipped through? Number of primary manufacturers in China, are they known? What's the compliance status of each of the companies? You can kind of get a feel for the level of granularity for these questions. What is the compliance character of each shipment or entry path? So he has some technical terms in there like entry pathway, what tariff classification is used. Okay, you get the idea, right? Now, so we got him down. We had to like get him down to like, well, here we have 14, but we stopped at 7. So I said, okay, 7 is a lot to model. So you get the gist of that. Now, column C is where the ontologist comes in now, right? So we're doing iterative feedback loops with Daniel, and when this is where the ontologist, we start to disambiguate the question or the problem, and we get pedantic, right? We're going to get down into the weeds. So when we ask the question, what's the country of origin for folic acid? Okay, Daniel, what do you mean by country of origin? What do you mean by folic acid? And what are the varieties? What are the uses? So the very specific questions that, as an ontologist, you're already kind of looking towards the knowledge graph and the classifications. So column C, these competency questions lend themselves, or they're pointing towards this column D, right? So by country of origin, what do we mean by that? Are there potential classes, right? And you can see, let's use, for example, what are the varieties of folic acid? Now, remember, I didn't just make these up and start building the ontology. I made these competency questions, and I went back to Daniel and said, hey, what am I missing here? Is this right? And so that competency question derived from this decision support question, and then you could start to drill down, right? And you get this column D here, potential entities or classes or instances for the ontology. Now, as you can see, if you go from DSQ to competency question to column D, you see a lot of up to when we ended up with almost 90 potential classes. And again, another feedback loop. I sent it back to him. I said, hey, Daniel, can you look at column D now and see what I'm missing? See if you want to add things. See if, and do we need to get on another call and go through these? He was very fast at then taking column D and adding to it, revising, helping revise it. And yeah, so he was a very good person to work with. Now the column E there, the next part of our method is to then say, hey, let's find existing ontologies. Let's look through them and see what already exists. Let's not reinvent classes when we have experts that have already made those classes. Now, right out of the gate, you're probably noticing, well, geez, Bill, don't these classes already exist somewhere in ontology? They probably do. But like I said, we were doing this on a very short time span. And so I probably missed a bunch of already existing content. And anywhere you see new, it was like I just couldn't find an existing class somewhere. Given more time, and this was not his primary job either. He was just doing this for the Ontology 101 sessions. But given more time, we probably could have found more already existing classes in their IRIs, right? And he went in and anything that needed a definition, boy, he went through and he defined all of our new classes. Right. So the point of the spreadsheet exercise, we haven't even talked about, converting this to all RDF, but we took the spreadsheet and we pulled it into Protege. We got it into an OWL file, right? So now what happened there, I'm going to bring that up and show you. This was the finished product here, right? So now we have, and you can see, and I'm sorry it's so small, but you'll get the point here. You can see the tags for basic formal ontology, and that goes down to common core ontology, and then we called it the USO, the Uruguay supplement ontology. Okay, and we built that out. Let me bring that a little bit more, make it a little more granular for you. And the whole thing, let me just get an example here. So in material entities, right? So we got portion of processed material, a regulated product. So the point here being is you go from basic formal ontology, material object, and then common core ontology you see in red, and then you see a new part of the taxonomy that Daniel built for the regulated products, botanical ingredients, cosmetic products, supplement products, right? So these are all the things he wanted included in the ontology. So now we had processes, we had organizations, we had the processed portions of ingredients, we had different processes down here, compliance processes, right? We had a lot of what we call GDCs, or information content entities, right? So we had things like performance specifications, intended use statements, right? So this is all this is his use case. These are the things that he wanted included. And so we then want to start adding individuals to this, right? So let's go to vitamin supplement product. Oh, and now of course, my proteges having fits now. Here's the point of this one. If you can see my graph here, this design pattern. Here at the bottom, you have a vitamin supplement, a product, right? And it has certain ingredients. Now you can add whatever ingredients you want to that. And that is prescribed by some ingredient specification. And that is also prescribed by some use statement, supplement use statement, which complies with the Uruguayan supplement regulatory framework. Those are the types of statements he wanted to be able to query, the design pattern that he wanted to be able to query. So now from this, he has circled back, and I'm going to bring this back over. That was our end-to-end process, and he is now going back to try to get funding so that we can do this here. So that's our weekly we just started a new set of 6 weeks, and we don't have a subject matter expert. This iteration of the Ontology 101, we have mostly postdoc and younger people that are trying to break into ontology. So we're probably going to go back to that more Ontology 101. This was just a case where we had a real world expert in there. We're hoping to get some from maybe aerospace or some other field, but this was just, I think, John, the reason John wanted me to present this is because this kind of just happened. That it wasn't the plan. But yeah, so I'll open it up for questions or comments at this point. There it is.
Mike Bennett had a comment.
Yeah, so I had a comment. Looking at this diagram here, excuse me, they have regulated product, but being regulated is not an inherent property of something. So
Yeah,
normally you want to try and create a coherent, if you follow something like OntoClean, a coherent taxonomy of things defined by their actual intrinsic features that distinguish one thing from another. Any
yeah,
product can be regulated. So whatever product is a regulated product is also whatever kind of product it is. So you
yes,
would ideally have a second hierarchy of a contextual notion of a regulated product pointing to what is a product that is regulated. As soon as you make a
yeah,
subclass like this, you're breaking that kind of that rules of having a kind of a rigid types of thing with a single hierarchy, and BFO which you're using requires single hierarchy anyway, so you're
yeah.
going to get in trouble for that. But that's
Ye-
a whole other matter.
Mike, duly noted. There was a little bit of cheating going on here, and it's the same thing I had when I was in the intelligence world. They had fixed wing aircraft used by the Italian Air Force for reconnaissance missions, and I'm like, oh.
Well,
So
there's a very easy way around that, just by partitioning your ontology into a thing in itself versus a relative thing or thing in a role or context.
yeah,
Then those problems go away. And even a lot of OWL experts really struggle with that for some reason.
yeah, 100%. Great point. Duly noted. There was some cheating going on. Shortcutting, I guess you'd say. Yeah.
Bill, this is Todd.
Yeah.
Um, I'm assuming that you're doing most of your stuff in OWL, but do you spend any time with Common Logic?
No, what do you say? Like, what? I would love to do that. What do you mean by that?
Well, this is Ontology 101, and you could separate that into two
Yeah,
types of lessons, if you like. One is the analysis part. What is it I need to represent? What are the
yeah,
distinctions and so on. And then the other is the formalism. How shall I represent these distinctions in some appropriate language with which I could do reasoning? And of course, the standard at this point is OWL.
yeah.
Most people are familiar with it. There are a lot of tools for it. But the better language, of course, and if John was here, he would jump up, is common logic.
It's common
Unfortunately, there
logic,
are
right?
fewer tools for that, and it requires, shall we say, more understanding of reasoning.
Yeah. So right, and again, the ontology 101 call is not supposed to be so structured, but here we are. So I absolutely will factor that in, and we'll make that part of it. I
Um,
guess I'm just
now,
assuming that, yeah, go ahead. Go ahead.
I'm sorry, there's a delay in my audio because of the
Yeah,
satellite connection. Um, Now, we have learned that Buffalo, University of Buffalo, or SUNY Buffalo, historical name, now has this course or courses or program for ontology. Do you know if they are, well, two things. One, are you associated with that? And in any case, do you know if they are using common logic in any of those courses, or they're just sticking to OWL sorts of things?
I I'm not really part of that. I do know, I do hear about the courses that they're developing. I have been asked to do a course on social ontology. Um, I I'm assuming that because John Beverly's heading that up, that there is going to be that um, that the common logic is going to be part of that. But I don't know that
Oh,
for certain.
okay. I could probably ask Barry next time I speak with him.
Yeah,
I
yeah.
have forgotten to ask him.
I am scheduled to I'm actually in the process of developing the curriculum for a social legal ontology course for that program. But that's all I'm not really like part of the official lineup there.
Um, how would people learn about your sessions here, Ontology 101? This is the first time I've heard of it, so I feel
Yeah.
kind of ignorant to say the
Oh,
least.
I apologize for that. So this was because John's so busy, he's got so many pokers in the fire. He's like, hey, and someone nominated me. They're like, hey, Bill can help, fill in the gap. And then it just turned into like a full time, like I'm doing it all the time now. So it was kind of an impromptu thing, but all you have to do is just send me a message. And if you have people, and honestly, if we get more subject matter experts in there, um, that it makes the class more interesting than just having me up there yammering.
Oh,
Um,
yes.
so
And especially
if you just set here,
if
I'll
you,
put it in the chat. Where's the
oh,
chat?
okay. Yeah, if you
Just
have postdoc in these classes and you have a domain expert, the
right.
postdocs could learn how to do effectively requirement solicitation. As you pointed out in your presentation, you'd have to keep asking more and more questions to figure out what the hell they're talking about.
Yeah, and so this is John and I have had this conversation over and over and over again. What is really what is it that we do if we can capture it in a phrase? And if you I like disambiguation because so many of these efforts that I've been on in the intelligence community, in aerospace, I've worked in military operations and intelligence. Um, it's disambiguating, and
Hmm.
just last week they said, "Hey, this high level person in this government agency said, hey, we've got this data dictionary or data lexicon. Can you look at it?" And as you all know, it was horrible. I I picked out 5 terms as an example, and they all um, were they completely were illogical, and they contradicted each other. And I just fixed it a little bit, sent it back to him, and he's like, "This is lovely. I need more of this." And so that ability to disambiguate, that's the what I'm trying to portray to the participants, not the students, in the ontology 101, is this ability to disambiguate and to elicit, to pull out of the subject matter expert, to pull out those questions. And through that process, even though there's a little cheating and corner cutting going on there, as was pointed out, um, and then I've had, well, in manufacturing, I think of an example. I had this person that was a high level manufacturing executive, and he said by the time we got to that certain column where he could see the classes and then see them going into the graph, he was like, "Bill, it's as though you've pulled my mind out and put it into a graph." And I said, that's what we're that's what we're here for. And then he could see the gaps in his
Yeah.
thinking through the knowledge graph, if you want to call it a knowledge graph, where we had all of right, and we had it down to the machine level. There's a machine on the floor that's doing this testing process, and that's what's slowing you down. And he saw it in the graph. He's like, "This
Yeah.
is it right here. This is what I needed." It's like, so
Well,
I'm going to
that's
put my
good
name
training.
in the chat here, or my email address, and
And
yeah, go
while you're
ahead.
doing that, let me ask, do you contact, oh, first of all, one, the John you are referring to is John Beverly, correct? Not
Correct.
John Soa. Okay.
John
And
Beverly. Correct.
do you contact Barry or speak with Barry very often, Barry Smith?
I speak to him 3 times a week.
Oh, good. Could you badger him about, I think, a problem in BFO? And the basis is it has to do with communication and using natural language for communication, which Barry sorts tries to avoid, though I keep bothering him about it.
Yeah,
In
yeah,
BFO, in BFO, the OWL representation, I guess in BFO in general, they have they use the natural language label in here, and its inverse is bearer or bears, whichever,
yeah.
and that is
Bearer.
incorrect. The natural language definition of inheres talks about something essential to an entity, whereas to bear something, is a temporal aspect depending on the situation or context you're in. It's not essential. So the fact that they're making bear or bearer, I forget which one it
Bearer
is,
of. Yeah. Bearer of.
okay,
Yeah.
as an inverse of inheres is incorrect.
Ah,
And I've been badgering Barry about this for some time now, and he just tries to dance around it.
I will help you badger him.
Thank you.
Yeah. So you've got my email now. and
Okay.
that's an interesting distinction. I
Well,
did not know that.
well, again, one of the things I harp on, I'm chair of the technical committee in the Industrial Ontology Foundry, is the absolute necessity of having natural language definitions before you can get anywhere near formalization.
Yeah,
So there should not be a great disconnect between your natural language definition and the formalization of that. Now, I realize natural language is necessarily ambiguous, but we are using ontologies to communicate among people, in addition to having machines communicate among themselves and also having people communicate with machines and vice versa. So the basis for that is natural language or symbols, or there could be physical actions like I walk up and I slap you on the back or something.
yeah,
That's a communication mechanism. But communications is at the heart of this. If we didn't have to communicate, we wouldn't worry about interoperability. We wouldn't worry about doing ontologies except for our own
yeah.
amusement. So
So
that's my position.
are you so is that an argument for every class of thing should have both a natural language definition that you would say get out of the Oxford English Dictionary, and then you can get as pedantic as you want with a sort of like a an
Yes,
ontological definition.
it,
Yeah,
it's not just classes, but also any relations, whether they're binary, ternary, whatever. The reason being, if people are going to use an ontology, they have to know how they should interpret those symbols, right? Again, one of the problems with using natural language terms is that we confuse them with the way we use it in just, common communication or conversation. But logically, those are strings of symbols, or that is a particular symbol in a non-logical symbol in your language that you're using to represent something, and you
yeah,
have to be able to understand how to interpret that non-logical symbol.
yeah,
You know, if you use alphanumeric character strings, okay, that sort of, to some extent, removes this bias that you have as a human. But when you actually try to work with things, you're going to go back to the natural language discussions or descriptions or whatever.
So you're a fan of opaque IRIs or not, or you don't?
Oh, well, that's another discussion.
Okay.
Yeah, well, I don't know. I'll put it that way. I prefer non-opaque IRIs, but I understand they can be useful. Yeah,
Yeah,
I don't have
yeah,
a clear answer to that one.
I,
Sorry.
yeah. Nor do I. I get both sides.
Okay,
Um.
Well,
we're starting to get a lot of
if you,
comments.
okay, I'll
Um,
be quiet. Thank you, Bill.
Hey,
okay,
real quick.
thanks, Todd.
Yeah. Go ahead. Go ahead, Ken.
So there's a comment from Victor. Do you wish to speak?
Wait. Let me find Victor here. Oh yeah.
Is
There's lots
Victor?
of comments.
Yeah, I can speak, I guess.
Yeah, Victor. Go ahead. Yeah. Just say it. Yeah.
Yeah, I'm inherently a data guy, so I view this analogous to relational database design, where you get hit with a whole stack of non-normalized data and you have to make pass after pass after pass, talking to knowledge experts, converting it down to third normal, eventually getting it down to a whole bunch of really clean, mutually exclusive dimension tables. But albeit I think with the ontology, you carry it a step further, multiple steps further, where you go beyond that, starting to look at not just how you store and access the data, but also the existence and the reality of things and how they are actually related more than the components of how they might be accessed or stored. Essentially, what I'm calling more of a semantic normalization
Yeah.
as
Yeah.
an extension of a third normal normalization. But I tend to find that people who are good at building data architectures for data sets have sort of a natural aptitude for this, or they sort of already think in these sort of hierarchical blocks. Of course, that's assuming they're not some EAV person or other type of database design. But anyway, I'll be quiet. I'm sorry. It was just a
No,
thought.
that's a great comment. And back to the point about my my kind of cheating over here on the left, if you can still see that. That point about that I made about the fixed wing aircraft used by the Italian Air Force for reconnaissance. That I was not kidding about that. That was a real class in an ontology, and I said, listen, just unpack all that and let just, we have this thing called the principle of consistent difference or differentia. If you're going to use structural differentiations rather than the role that something's in, then do that. Don't do what I did here, that you're saying that there's this thing in the world that's, oh, and by the way, it's regulated, so we're going to make that a parent class, that it's this regulated thing, instead of saying, yeah, it has this structure and it maps up nicely and much more scientifically, and oh, by the way, we regulate it. So that's another assertion that we want to make. I just kind of put it all together and cheated here. So my apologies. Good catch. Yeah. Okay, go ahead.
Okay, then there's Paul Tyson.
Paul, do you want to come off mute?
Well, that was just a side comment based on someone's question about common logic. I've never seen a head-to-head bake-off between those. I have minimal experience with common logic, but just the act of, say, defining and declaring a class seemed much more cumbersome in CL than in L. So I just wondered if someone has fully developed a comparison and when, recommendations, when to use one or the other and that sort of thing. That's all. We don't need to get sidetracked by it here.
Yeah, this is a great point, though. I definitely want to, I kind of just let the 101 weekly session just kind of meander. And I definitely want to bring this conversation into that. John, you got your hand up. Why don't
John Sawa, you have
John.
something to comment on? Can you add to this discussion? John? You're muted.
Okay, point is, common logic has everything. Every version of logic that you've got is in common logic. So if you've got common logic, you have everything. Anything you represent any other way, you can represent in common logic. And the point is that there are excellent tools that are super fast. And people say, oh, that's too much. No, it's not too much, because common logic, anything represented in common logic, can be processed with the best processes available. And if the complexity depends entirely on the application, it does not depend on whether you're using common logic or anything else. The point is, however, you must have some good tools, and there are some. And what we're using in our Permion system is really a super fast version, and it represents everything.
Lovely.
Okay.
Yeah.
Victor, do you want to add something to this?
Yeah, I was in my natural language processing experience, and this is a question, so excuse my ignorance for the geniuses all on the call. But one of the problems we've had this speaks to a question that was brought up a few minutes ago, was about the difference between a true semantic meaning of perhaps a word or phrase, and then perhaps how it might be commonly used or used in context. And then creating sort of a crosswalk for those. But in addition to that, I'm wondering, does the ontology ever consider the probabilistic nature of the incidence of occurrence? Because NLP does. So it'll say, well, I think it means one of these three things, but it's most likely to mean this one. And I don't see that in at least the stuff that I've read, but I'm a bit of a novice, so excuse my ignorance here. It's a question, not a statement, or a thought anyway.
Okay, that depends entirely on the system that you're using for processing things. Now, what we're doing with our Permion system is that for any particular application, we're using an application that is precise for that application. And when we get a sentence coming in, say, in English, for example, we translate that to our internal representation, and then we come out with an echo that is a precise translation from the internals to English and say, is this what you mean? And if the person says yes, then that's what we go with. And if the person says no and corrects it, then we have the dialogue so that the exact meaning does not come from the source text. It comes from the source that was translated to an internal form and then goes back out to an echo. The echo is an exact mapping from the internal to English. And if the person says yes, then that means that the internal is correct. If the person says no, then you carry on a dialogue until you get it, until the person who's using it says, the English that was generated from that is exactly what I mean, and then you push the button and execute it. So the point is that the resolution of any possible ambiguities comes in the dialogue between the computer's version of English and the human. And when the human agrees with the computer, then you go with that.
Yeah, and that makes perfect sense, being able to have that bidirectional reaffirmation and validation. I guess my question was a bit bigger than that, and I was thinking more in the terms of even like psycholinguistics, where you might know that certain hard consonants are used more than others. So if I've got a noun, say house, it might have a particular meaning most of the time, but have alternate meanings less times. Some of that I know has been documented as percentage use, at least in common language. And I was wondering if there's anybody working to take that probabilistic nature and apply it, because if you look at a larger platform, an LLM like Google or Anthropic or whatever, they're dealing with this massive public use case where it's hard to get affirmation. They simply get it right or get it wrong, or told they're an idiot by the customer right when it's happening, I guess, and then learn from that. But I was thinking it would be nice from a linguistic standpoint to have a sense of how common specific meanings are in the use of the language, and be able to even tier that some level, to have the word by itself, the word in context, or the word in shared context. Because I know in NLP we would like group words by, X a number of characters out or words out or sentences out, and trying to do that matching. And also knowing that domain class, so if you're talking to NLP for a doctor versus somebody who's a child playing a video game, you're going to get a completely different matrix or association table. I'll be quiet though. I'm sorry. This is all very fascinating, and I very much enjoy these. So thank you.
Victor,
just a
let me
short
just
comment.
make a real quick point. And John, I'm sorry for cutting you off. This popped into my head. This was a paper where they took almost 1 million maintenance work orders, and they asked the question, when you say maintenance activity, what do we mean by that? They got it down to this list right here. I don't know if you call this lemmatization or what. They got it down. This is of the 800,000 plus documents. This is what they mean by maintenance, those activities right there.
Okay, just one comment about natural language processing.
Yeah.
There is 70 years of processing of natural language, and the answer is it's a huge amount of work done on it, and the best translators do an excellent job. And there's no simple answer. And the basic point is that nobody who is not an expert in natural language should even attempt to do it, because there's 70 years of work, 70 years of very detailed, complex work. And I'll send a note to Ontolog Forum going into more detail with more references on this topic.
So
Thanks, John.
The other fascinating thing about this paper, and I'll stop talking here in a second, is the most valuable information in these maintenance work orders, the 800,000 plus, was not in any of the drop downs. It was in the natural language of the maintainer, the mechanic, what they wrote in their comments. And that is the bottom line right there. Those are all the maintenance activities that we really care about right there. Okay.
Well,
Okay. Now to kind of switch things a bit, Gary has a comment. Gary, go ahead.
Okay, I had several postings in the chat. They're more detailed than we could really take up here, but Bill might look at them later on. He had a table in which he couldn't find essentially ontologies that covered some of the chemicals.
Yeah. Yeah.
All I did is I made a snapshot of that list and asked an agent to come up with definitions. That was the first part. Then I said, okay, can you axiomatize that? And it gave me turtle files on that. And then I
Nice.
took this diagram that he has, ontograph, and I took a picture of that. And I said, can you convert that into axioms with turtle? I assume Bill has done something like that behind the scenes. But the point was that the agent could do that. I posted, took a couple of postings, but I posted the results in there, what it thought, and then I asked it to generate another diagram based on what it had done. Again, so that could be viewable. The
Yeah.
point of all of this is that I find in the knowledge, the little limited knowledge engineering session I do now as a retired person, as part of Earth Science Information Partners, for example, some of the things that are going on there. I can use agents to really get a very good start on some of these things and create sort of starting ontologies that I now then run by the domain experts and the vocabularies they're interested in and the use cases they're interested in. So I don't know if anybody else is doing that, but it seems like an obvious step.
Gary, after this 6-week session, I did just that. I created an ontology engineer agent at pretty much along the lines of what you just described.
That sounds great. Okay, anything else, Gary?
No. Just that Bill can take a look at what's been done and see if that produces any new understandings or he finds fatal flaws in it, which is also, I mean, I find flaws in it. Things like when I look at it from chemicals, a catalyst, it lists the fire as a catalyst because it takes a common definition of what fire does as opposed to a chemical view. So you have to do things like that, but still, it's a help.
Good,
But
good.
again, catalyst is a nice example of a relative thing, and I don't think any natural
Right.
language corpus is good at extracting relative things or things in roles or contexts, or whatever you want to call them. Catalyst is a really nice canonical example because nothing is a catalyst in and of itself in any thing. It's only in specific situations of a specific reaction that something is or is not a catalyst.
Well, if you take chemistry as a starting point, then it's a chemical catalyst, but you can think of strictly. And since I was working with a chemical ontology, that was the relevant part. But then there are analogous things that we
Oh,
consider
no, I was just thinking
catalysts
the
in other
chemical side.
situations.
Yeah, but then presumably the analogy, I was thinking purely of chemical catalysts, but yeah, presumably the analogy only applies when it applies. So you look at another kind of contextually relative thing in a context other than chemistry in which it hurries some process along. Otherwise, it's not a catalyst.
Okay.
So, Mike, so these things where we very quickly, instead of categorizing something based upon its structural elements, and we put it into a role, what's your technique for avoiding that?
So I don't avoid it, I do it.
You do it, yeah.
There's
Okay.
two ways of doing it, really essentially two subtly different conceptualizations of the same real world matter. The one I use, John Sower's knowledge representation lattice, but only the top layer, I'm afraid, John, and that's independent, relative, and mediated thing. It's really easy to explain to subject matter experts. They get it. Then every relative thing has one compulsory object property pointing to, well, what is the actual kind of thing in the world that performs this role or function or people often think of it as roles. That's why I use catalyst as an example because it's anything relative. The other technique, which you see more in languages like UFO, although they still have that notion of quiet entity, they prefer, and it makes some of the data modeling subsequently easier, a subclassing in which it's a very specific facet of a subclass, which is not a intrinsic property. So it helps if it's stereotyped in some way to say, this is a person that is also a teacher, as distinct from the quiet entity thing of this is that which is somebody being a teacher. So
Yeah.
those two ways of conceptualizing what is essentially the same stuff going on in the world. I prefer the relative thing approach. It just gives you a nice clean partition right from the very top. Under thing, you have independent relative mediating thing. The mediating thing is the context.
Yeah.
Sometimes the context is some other thing. That gets a bit tricky to model. Like the organization is the context of somebody being the managing director or something. Then you've got to somehow equate organization as a thing with organization as a context. So there's some tricky bits like that, but it cuts
Yeah.
across so many of the problems people have, and it drops out
It-
of using OntoClean. OntoClean forces you to have, a hierarchy of purely intrinsic things. So all those extrinsic things, you got to put them somewhere, put them in another partition, call it relative thing, and away you go. And you can solve in 10 minutes things that I've known ontologists spend 6 weeks trying to figure out.
Yeah, and this permeates everything. I was thinking the other day I was eating a steak dinner and the portion of meat on my plate, I was like, this isn't food. This is a chunk of muscle that came from a cow.
Exactly.
It's in a food roll.
And relatively, it's food, and also it's an ingredient. And
Yeah. Yeah.
yep, ingredients, another nice example. And is the context the recipe or the piece of food? It really,
Yeah.
at that point, it depends on what you're contextualizing or what you're conceptualizing, how you're carving up the world at the edges. This is why I kind of diverge from Todd and others on the idea that you have to always come back to the human readable definitions, because when you really get down to the meanings of things, most of the time they end up not really matching our words at all. When you've got really coherent categories of thing, you find that human words are just hanging about looking like a bad smell because they don't quite fit.
Yeah.
Okay, Michael Cabela's still here. You had a nice comment. Good question. Let's see.
Mike, I don't know if you want to come off mute or I can. He said, when modeling a domain, in my opinion, you seldom use the natural language definition. That's far too expansive. In a general NLP ontology, speed and velocity are synonyms. In a physics ontology, velocity is a vector and speed is a scalar. The same is true for classes like product, purchase order, etc.
It doesn't appear that Michael is still in here.
Hey, Bill, Kenneth, can I
Yeah,
respond to that comment that
sure.
Michael made? Let's see, when modeling a domain, you seldom use the natural language definitions. Okay, if you're modeling a domain, where do you start?
Right.
So, I mean, you have to start somewhere. Now, I would agree that as Michael, I'm sorry, Mike, I just forgot your last name. Where's my
DeBellis.
brain?
Like
Cabela's,
Bennett.
No.
Like Cabela's.
Bennett. What Mike Bennett just said
Mike
that
Bennett.
when you, well, I was going to refer to what Mike Bennett had just said in terms of natural language definitions and in respect to the formalizations that you may derive. Yes, there can be some disconnect between those two. But as I mentioned earlier, we have to be able to communicate among humans. So what are we going to use? And yes, you need to start with natural language definitions, and you may need to modify them, and they're still ontology for your representation. But again, you have to start somewhere, and you want to be able to communicate with other people. That's my retort
Well,
to Michael DeBellis.
Todd, I would comment on this.
Okay.
Let's say Bill's running his session. He starts with a domain expert. A domain expert isn't necessarily going to be fooled by some of these common uses because that person understands a technical language in a field. The other thing that you have is you might have an existing ontology you're trying to expand out and fit in. So there's a big difference when you're discussing this with a domain expert or an expert in some area and just a layman in a general conversation about things.
Yes, I know. But the question then becomes, what are the goals? What are the requirements for your representation? Is it only going to be used by domain experts? And in fact, you should be aware that Domain experts don't always agree to the extent that you
Yeah.
might need them to for an ontology representation. So again, what are the requirements? Who are you creating this ontology for? How will it be used? What competency questions do you need to answer? That can decide whether you need you have to have, maybe you need some ambiguity because and again, it depends the type of ontology you're developing. Is it BFO, that foundational level? Is it a reference ontology? Is it a sort of a
Yeah.
mid-level ontology? Or you're down dirty with an application ontology? So it
Yeah, and
depends.
so another problem to add to that is when you have a room full of subject matter experts. In the case of Daniel Maybe, he's not an expert in folic acid and what you can do with it. He's an expert in the regulation aspect of regulating the manufacturing and how the countries interact. So his area of expertise, you got to pull in someone who's also an expert in folic acid and how it's used. That again, not his area of expertise. So who are the experts in the room and what are they an expert in? And so that's why we go back to, okay, what are these decision support questions that you're asking? And do they kind of tell us the direction we need to go in? They do, hopefully.
John still seems to have his hand up. I'm not sure if he just didn't take it
John,
down.
are
Or
you?
Oh, no, I
say.
wanted to make just one comment, and that is that the technology for the natural language processing is very, very good. But the point is, you have on the language of that the computer generates is based on the exact ontology for that application. Now, the people who use it may have their own ontologies in their heads that may be very different, but it's by that dialogue where the human says or writes a sentence, it goes into the computer interprets it, and then comes back with a precise statement of exactly how it interpreted it. Now that interpretation is exactly one-to-one mapping to the implicit ontology of the computer. And then by the dialogue between the computer and the human adapts to the computer's ontology. So that the computer never adapts to the human ontology. It's always the human who is forced to adapt to the computer ontology. And by means of that dialogue, you can always resolve it down to where the point is that the human is talking to the computer. The human learns, it's easier for the human to learn what the computer knows than for the computer to learn what the human thinks.
Yeah, and
Another
so for just real quick, you look at this folic acid 4D decision support question. What is the compliance status of each company? Well, in order to answer that in the graph, you have to define what do we mean by compliance status, and does that already exist somewhere in our ontology? And then by company, right? What are the types of companies, manufacturing companies, whatever? So this DSQ is dependent upon what else is already in the ontology, and so the subject matter expert. Once Daniel saw that, he started to realize that, okay, all these questions, there's elements of them that map to each other.
So I was going to just have a very simple reaction to what John said, which is that the knowledge engineer is typically working in the context of an ontology. As he said, that's the base. The human contexts are very varied, but usually the agreement with the knowledge engineer and the domain people is, I've got an ontology or developing an ontology, and that's going to be the base. And that's how we'll judge things. It grows incrementally as people add to it and get more understanding. But as John pointed out, the ontology is a definitive base for this understanding.
Yeah.
Okay, there's Paul. Are you still here, Paul? Paul doesn't have a mic capability, so I thought I'll mention this. Could non-structural characterizations like regulated be placed in the annotations attached to a class, perhaps in a description on annotation?
Yeah. So are we saying just vitamin ingredient would map? I don't know how you would do
I think
that.
we're
Yeah.
circling back to something that we previously discussed.
Yeah. So
Um,
make the fact that it's regulated, just make that an annotation in the class.
But if
yeah,
you
the
do
difficulty
so,
with
your reasoner will not know anything about it.
yeah,
So
there's
it
the
would be good
reasoner
for
won't
Right.
humans.
do anything with
Yeah.
annotations,
Right.
and you do want to reason about it. John,
John.
Yeah, I'd like to just summarize it in one point. For any particular application, the computer has a precise ontology for that application. And in the dialogue, the human is forced to adapt to the computer, what the computer is doing. The computer never adapts to the human. So the computer really is restricted to that application. And by means of a dialogue, you can design really good dialogue handling so that the human eventually learns exactly what the computer is doing. And eventually the human knows that this is what the computer does, and the human adapts pretty well to mapping to and from the computer.
so John, does that include inference rules? Axioms,
The
logic?
inference rules are the definition of what the computer knows. So all the inference rules are part of the computer knowledge. So for this, the knowledge of the application. So different applications may have totally different mappings to and from natural language. But for the particular application, the human must adapt to the computer, and you can design good dialogue handling so that it that the human eventually learns exactly what the computer is doing, and the human can pretty well have a pretty good mapping to and from the computer, but it's always the human who has to adapt. The computer does not adapt. Its application is fixed. There's no
Yeah, and
change.
John, this was an argument. Now that you're saying it, it's making more something I had argued in the past is that intelligence analysts had to write the reports so that they were matching the way the computer reasoned. So there was some social engineering going on. You want better intelligence reports? The analyst has to understand the ontology that the system's using.
Well, it's possible that what's implemented in the computer isn't correct for that application, and so there may be a need for the expert who knows what's in the computer to modify
Yeah.
the computer's knowledge. But if assuming that the computer is correct for that application, the human has to adapt to the computer.
Victor.
Yeah, I guess I'm going to disagree a little bit. I think for most part that's probably true, but I think a lot of these applications have configurations or anchor files or other methodologies where you can interact, and the computer itself will actually adapt to the instructions given to it, whether or not it's done through file, database, or by verbal interaction. And that's true even of the mainstream programs like just say Anthropic and Claude, where you can go in and tell it, I want you to speak nicely to me all the time, like I'm a layperson, or I want you to understand that, my phrasing and my questions are going to have lots of spelling errors, and to use the right. And once those are instilled into the system, it is just actually adapts to your instructions. Whether or not it does it naturally, I think there may be some partial components in there, mostly from a nicety customer service side of the house. But to your point about strict ontologies and the way they're stored, I completely agree. So, maybe 5, 10 years from now, Elon Musk will be right, and the robot will just adapt to you as quickly as it can, knowing what your predilections are and how you're even responding physically to the responses and reading your body language and such. So
Oh,
anyway,
I completely agree with that. But the point we have to assume is if the computer thing happens to be absolutely correct, the human has to adapt to the computer. But there's also the meta level mapping where you can say we want to expand what the computer can understand, and that's a separate issue. That's an issue where you're extending what the computer does. And so you're increasing the knowledge of the computer so that the next time for the new people who come in, they have a much more friendly computer. But the point is that whether it's a friendly computer or a nasty computer, when the computer application is finished and complete, the human has to adapt to the computer. But in the development stage, there's a stage where there's people are extending what's in the computer.
Yeah, and
So
this
John,
begs. Oh, go ahead. I'm sorry.
John, just real quick, John, where is there a definitive paper that states what you just said, so that we can go find that?
I'll send a note to Ontolog
Okay.
Forum with more information on this.
Sorry,
I've spoken to some robotics engineering folks, and one of the things they're excited about, and albeit it's 5-10 years in the future, is and I bring up Elon Musk again because he's an easy target. But the idea of the robotic assistants in the home are going to be designed to be Hive database based, so that what they're experiencing and learning and getting interactions of are actually not being shared for themselves to correct in that single interaction, but actually are contributing to the corpus for all of them. So as the numbers increase, the adaption increases and the knowledge increases. That's a pretty substantial logarithmic or exponential effect that I think will be very powerful. And I'll be curious to see what happens with that in a short period of time.
So I think for now, we have to distinguish different types of knowledge that we're talking about at times. I mean, the chemical knowledge, for example, in here is not going to change, but the way of interacting with a user in a style, for example, the social knowledge certainly could change.
Yeah, and so could the complexity of the interdimensionality between the metadata and how chemical terminology is defined and how it is used and understood across multiple domains could expand rather quickly.
Well, yes, that comes with the example of talking to a 6-year-old versus a technical person, where the style of engagement again is made to be appropriate. But again, the base underlying knowledge about chemistry, I assume the ontology is not going to change as part of that interaction.
My thought, though, is that if you build an ontology for one domain that uses chemicals, for example, and you build it for 50 others or 100 others, that eventually they all could be merged together into a larger, more complex, multidimensional one that actually works and is accurate, but actually is now suitable for the larger cluster rather than the specific domain, works within domains, but also works across domains. It's very difficult, I think, to master a single ontology across domains out of the gate. So this is sort of baby steps building, right?
Right.
That's why I said it'd be interesting to see what happens as this happens more and more and more, right?
I agree that's interesting, but to go back to John's essentially assertion is that all those multidimensionals adhered together essentially is what the user has to sort of comply with ultimately. There's many different ways of looking at the chemistry, perhaps, but that's all fixed in the computer, and ultimately that's the limitation of what the user can interact with.
Yeah, my point though is the ontology is being created by a fixed number of subject matter experts. And if you have multiple ontologies with different subject matter experts, they end up hiving, right? So it isn't that any one ontology is bad. It was custom developed for whatever that use case was. But it stops at the edge of the limits of the people that were involved in it. Whereas you have multiple, they can actually build on each other, and they can be done through deductive or imputation or other methodologies, even beyond the person themselves, and then validated after the fact, which is a little bit analogous to, I think, what John was talking about by getting feedback from those groups. So the system would come and go, well, you think it ought to be this way. What do you think? And then everybody goes, that's a great idea. We like that. And then keep it, that sort of thing. Right?
That might be a version of ontology maintenance.
Yeah, the point I would make is that you have to distinguish between the application, and so each application will have a precise ontology for that application, but you might have a system that has a huge number of different applications, so that you have to distinguish a meta-level discussion in which you're talking about what application you want to discuss, or what kind of reasoning system do you want to deal with. But once you narrow it into a particular topic, then that topic, the human has to adapt to the ontology for that topic. However, you can also have meta-level discussions in which the human and the computer are sort of in a negotiation stage, in which you're negotiating which particular issue are you talking about? At what level are you talking about it? Are you talking about an introductory level or an expert technologist level? So that you can have multiple domains, but within any particular domain, the ontology of that domain is fixed, and that is only thing that you can talk about in a very precise way. But then you can also have the meta level discussion where you're trying to negotiate which domain you're talking about.
I agree with all of that, but I guess what I'm arguing is that and I'll go back to the analogy I started with in the beginning of treating this like a normalized database. If you had a whole series, let's say we had 1,000 normalized database, a computer could go out there and find linkages between those databases that were rational and made sense that a human might not be able to see, or a certain domain group wouldn't be able to see. But once they were in place, it would vastly expand the capabilities of the specific ontology and the domain together. So I guess I'm saying everything you're saying is true, but I also think there's another dimension here that is sort of based out of this larger hive component, and that's what I was only inferring to. So sorry for all the conversation. I don't
So
think this really.
no, this is great, Victor. So in the graphic that I have up, slide number 10 there, in my mind, I look at this and I say, okay, the supplement use statement, that is an ontology that is distinct from the vitamin ingredient. So in other words, this prescribed by, this is bringing together two different ontologies. One is the subject matter expert is a chemist, and the other one is, I don't know, a developer who's wants to tell you how to use this supplement, right? So I could see where this prescribed by object property is unifying two different ontologies, perhaps.
Well, we've actually run a little over,
Yeah.
and I think at this point this would be a good point to adjourn. And next week we're going to have a synthesis session, and the week after that we'll start working on the communicate. So thanks to Bill for engendering quite a wide variety of discussions. And good luck with all of your Ontology 101 sessions. I think it's a great idea. We certainly hope that you will continue doing that in the future. And I hope everyone can come next week as we try to synthesize everything that happened in the second half of the summit. And with that, we will adjourn. Thanks to everyone. Thanks to Bill.
Thank you, everyone. Thanks. Bye.
Okay, so.